All right. Hey, everyone. My name is Donna, and this is Phoenix Fire. Today's live production is brought to you in part by Prairie Sky Recovery Centre in Leipzig, Saskatchewan. Prairie Sky Recovery Centre offers private intensive addictions treatment and supports medically assisted treatment strategies in Leipzig, Saskatchewan. If you'd like to learn more about our sponsors, head over to www.hardknockstalks.com. Today's guest, Dr. Kim Hellemans, teaching professor and associate dean of science at Carleton University, the co-host of the popular and award-winning podcast Minding the Brain, producer of several animations that explain complex neuroscience concepts, including stigma and addiction, a number of which of those can be found on YouTube, and faculty lead of the student-run social media campaign #StigmaEnds at CU, and is an engaging public speaker, just to highlight a few of the amazing things she's involved in. And we'll meet her right after this. I spent a year and a half on the streets. Addiction took me there. Pain took me there. My name is Donna, person in recovery, domestic violence survivor, mother of 2. I spent years running from myself, but no more. I've come to find peace, and I am not here to light a candle. I am here to set fire to the darkness and give voice to the voiceless. I hope you'll join me and my guests as we face the stigma around addiction and tear down the walls of oppression. This is not a safe space. This is a brave space. This is Phoenix Fire. Okay, let's bring in Dr. Hellemans. Thanks for joining us today.
Hey.
Is there anything you'd like to say before we get started?
Sure, yes. I know there's probably people watching, listening from all over Canada, potentially outside of Canada, and I just want to take a moment to acknowledge that I'm joining you all from the unceded and traditional territory of the Algonquin Anishinaabe people, now known as Ottawa, Canada, and I want to acknowledge that I am a guest and a settler on their land.
Beautifully put. So why don't you tell us a little bit about why you do what you do?
Yeah, thanks, Donna, and thank you for having me. It's a real pleasure to be here today, and I'm really super passionate about substance use health, and supporting people living in recovery and living their most best and well life. So I am, as you mentioned in my brief introduction, a teaching professor, but I've also have a 15-year research career really trying to understand how substance use disorders and how addictions come about. And I'm really interested and curious to understand more about why some people are more vulnerable to addiction, because we know not everybody who uses substances develops an addiction. So my passion comes from the fact that, like everybody here, I experimented with substances. I was a recreational drug user. I still am, right? I enjoy a glass of wine now and again. I was a tobacco smoker for many years. I've experimented with several other substances, but I was very observant, even like in my adolescence and into young adulthood, and even now as an adult, recognizing that some people, they seem to use, and it was what was motivating them was just keep on getting high, keep on getting drunk. And I could see even in my friend group coming out of high school that there are some individuals that really, it felt like it wasn't about the sort of social space of substance use, which is much more common when we're young adults and we're kind of experimenting. It's kind of like this bonding, peer use. It was really about that escape, and using substances was really, predominantly motivated by that desire to just alleviate pain, alleviate anxiety, alleviate stress and depressive symptoms. So as I was indicating, I was really curious to understand that, like, why is it that some people can, experiment with substances and they are okay and they don't have to think about it the next day. And some people, it becomes very compulsive, it becomes habitual, and it develops into something that we know of as substance use disorder. So that's sort of like, the kind of the why as to why I got into it. as a research scientist, because after I finished my undergraduate degree training at McGill University, I went on and I did my master's and PhD in psychology with a subdiscipline in behavioral neuroscience, because I was really interested in understanding how the brain changed with substance use disorders.
Wow, that is amazing. Just incredible. So can you talk to us a little bit about how substance use impacts the brain?
Sure. Yeah. So don't tell any of my students that I'm going to teach you something that I normally have a whole course on. But I guess what's critical to understand is that regardless of the substance, like I'm sure, I've experimented with lots of different types of substances, and we all know that they all lead to a very different psychological effect, emotional effect, physical effect, like it affects your locomotor activity or your behavior. And so nicotine has a very different effect on us than does, say, alcohol, which has a very different effect on us than cannabis. So bearing that in mind, it's interesting to say, well, regardless of the substance, all of these sort of so-called addictive substances all lead to a very similar outcome of compulsive use, which we know of as substance use disorder. So you might wonder, why is that? So every drug that we use as humans that has an addictive component to it has its origins. Most of them have origins in plants. So think about like cannabis, tobacco, even cocaine, the coca leaf. Heroin comes from the poppy. Mm-hmm. And when we ingest these substances, we take them in, first of all, in very different ways, right? So some are smoked, some are eaten, some are injected. They all get into our system and ultimately get into our bloodstream. So that's the first thing that has to happen is the drug hits our bloodstream, which we know the bloodstream is like a little highway that goes all throughout our body. And when the main target is, at least for psychoactive substances, it's the brain. So we get this huge flow of the substance, the chemical, in our bloodstream up into our brain. And once it crosses what's called the blood-brain barrier, which is not actually a literal like hat that your brain wears, like mostly like a barrier. The blood-brain barrier is the constellation of the blood, the capillaries that feed the neurons or specific brain cells. Anyway, so it passes through these little cells, gets up into the brain, and then once it's there, every substance has a unique target in the brain. So things like stimulants, things like which would include cocaine and amphetamine, act very differently in a different population of cells than things like heroin, which are the opioids and the opiates, which act very differently than, say, things like cannabis and then, again, tobacco. That said, even though they all have these unique targets in the brain and they impact our neuronal firing, they all have what are called a common target, right? So there's a circuit in the brain called the reward pathway, and it consists of a population of cells that are located kind of deep in the middle of the brain. So I've got my little brain model here.
Excellent.
Yeah, here we go. I've pulled it in half. Don't ever do that to your own brain. So you can see this is like, it's like an apple on a stick, and the stick is like the brain stem here. And the population of cells that we're interested in, I'm going to turn the wrong way, is like right around here, a population of cells that are called the ventral tegmental area. Don't worry, there's no exam.
Oh my goodness.
Unlike my students. These cells, don't worry. They're located deep in the middle of the brain here, and they release dopamine. So have you heard of dopamine?
Mm-hmm.
Most people. Yeah. So they release dopamine. So no matter what drug it is, alcohol, nicotine, cannabis, they act on this cell here, which releases dopamine all into the front of the brain. So whoosh, you get this like flow of dopamine, and it goes primarily into this part of the brain here, the very front part of the brain, but also another region of the brain that's located just adjacent to the ventral tegmental area. It's called the nucleus accumbens. Again, don't worry, no exam. And the nucleus accumbens is involved in our sensation of pleasure and reward.
Okay.
And so this is why psychoactive substances, addictive substances, even though different targets, commonly what they do is they give us a sensation of pleasure or a high, right? Mm-hmm. And that's because you're getting this flood of dopamine into that key brain region that is normally there and is activated when we encounter natural rewards. So if we eat a tasty substance, or we have sex, or we dance or play hockey, we get this like activation of dopamine. And the reason that it's there is it was evolved with our ancestors back in like caveman days that when they encountered food sources or a sexual mate, there was a part of the brain that said, boom, remember this, right? This is really important, because our ancestors were living in times that these kinds of things were unpredictable, right? Like we didn't have our like convenience stores, vending machines, Walmart, Costco. No, we had to like go out and like hunt boar, and that was going to be challenging, and we may die, right? So when we encountered those super tasty, high caloric food sources, poof, like wave of dopamine, I feel good. And at the same time, we're going to parts of the brain that are involved in, like I said, this front region of the brain here that's involved in planning, goal-directed behavior. Other parts of the brain that are involved in memory. So we can plan to go out and get those food sources and sexual mate in the future when we're hungry or thirsty or what have you. So back to drugs and addictive substances, we activate this brain region, and you can imagine what it does is it's saying, remember this, this is really good, it's really important, we need to plan for this again. So that, in a nutshell, is sort of the basics of how substances impact the brain. There are lots of other brain regions, but we don't have 7 days. So I'm sure you can ask more questions, but that's sort of the kernel of it. I'm trying to put my brain back together.
I can relate.
Yeah.
So, is there a genetic disposition to addiction?
So a little bit of yes, a little bit of no, right? So when we're talking about like things that like why some people develop substance use disorders, why some people are at risk or have a propensity to develop addictions, one of the things I want to emphasize is, yes, there are people who, they develop addictions, and there's not much is known as to why, right? Like that's one of the things that some people, an individual might ask, like, why me, right? Like, why me and why not this person or this person? So I'll first focus on the non-genetic reasons, if that's okay. So one of the first things that we know that can confer risk is early life trauma. So an individual who, and I listened to in your intro, you said you're a victim of domestic abuse. This is an example of one of these traumatic instances that can confer risk or increase vulnerability. And these can be highly acute and severe traumas. So, content trigger warning here, we are going to talk about some heavy stuff, but they can be things like, being a victim of rape or sexual assault, or they can be very long, pervasive chronic traumas, such as the experiences of neglect or poverty, war conditions, pandemics, right? So these kinds of things, what they're doing, or what these traumas do, is they act on brain regions that are involved in processing fear. And again, much like the reward system, which is there in place so that we can learn to approach things that are necessary for our survival, traumas teach us to avoid things and fear things that might threaten our survival. And I'm not going to go too deep of a dive into it right now. Happy to answer more questions later. But in sum, what that does is that traumatic experience rewires circuits in the brain that are implicated in both fear and reward and decision making. And you can see where this list is going. And so what happens is that some individuals who have had these traumatic episodes and haven't had a therapy or treatment or acknowledged the trauma, which is challenging, because in our society, we also stigmatize and right? So we don't actually address these things. We get these altered reward circuits. And what happens is your fear circuit is ramped up and your reward circuit is lowered. And we take substances, it does this, right? So our fear goes down, people feel safe, right? That's one of the things that individuals with lived experience will indicate. I feel safe, right? I feel safe, and this is what it feels like to feel normal, right? So the brain is very plastic. It has a lot of plasticity built in, meaning it's learning what to do. And when one feels scared or one feels thirsty or tired, it will learn to approach those stimuli, things in the environment that predict this feeling safe and feeling good. And so that's in sum one of the things that we know of, and there's a good literature, huge bodies of work that show that experiences of early life trauma change the brain circuits to render an individual more vulnerable to addiction. So to your second question about genetics, this is always one that everyone's like, is there a gene? Mm-hmm. Spoiler alert, no gene for addiction, no gene for any major psychiatric illness, right? Like when we think about how genetic involvement for anything to do with the brain, we know like the areas that we know have more genetic involvement are neurological conditions. So neurological disorders like Huntington's disease, there's some genes involved in Parkinson's, Alzheimer's, autism. But with psychiatric disorders, things like depression, anxiety, PTSD, substance use disorders, there isn't much genetic involvement. You can inherit like a bunch of different genes that can put you at risk for depression and anxiety. But it's not like you inherit that gene and you're going to develop depression. Does that make sense?
Right.
If anything, you inherit these small changes in your genetic code. They're called gene polymorphism, poly meaning many, morph meaning shape. So different shapes of these genes that can, in combination with environmental input, can put you at risk. And this is the so-called concept of epigenetics. So you can think about genes load the gun, environment pulls the trigger. So we know that there are certain genes that can confer a risk. And then in addition, with all those stressful life experiences or even drug use itself, can unlock the expression of certain genes that make it more likely for somebody to develop substance use disorders. And the one substance that we know has more of a genetic link, interestingly, is alcohol. So there are certain genes that we know are associated in particular with the paternal line. So sons of male alcoholics. I don't like using that term. It's stigmatizing, but that's the actual terminology that's used in literature, are very much, see, hello, raising my hand there. So there is a much more of a genetic line with sons of male alcoholics, and exactly what genes, we could, again, I don't have 7 days and the gene stuff it's like long strings of letters and, there you go. Very long-winded answer to your question.
Well, I mean, it's a very complicated question to answer. So, I think that was an amazing job. For me, I would have still been rambling on forever if I had any idea, but I don't. That's why we have you here.
All good. We're all like, we all have our expertise and our
True.
strengths.
That's very true.
Yeah.
So we may have answered this question already, but you stated that drug memories are long-lasting and activate parts of your brains involved in decision making. Mm-hmm. Can you unpack that a little bit?
Sure. And this, and I want to address the fact that one of the most stigmatizing beliefs about addiction and substance use disorders is the belief that addiction is a choice. And for those joining that are, have a history of lived experience or have loved ones that have lived experience or are actively using, we see this, it was self-stigma, right? I'm in this space, I'm using, it's my choice, or other stigma, people believing that somebody has these stigmatizing beliefs about somebody else, which becomes internalized. So I want to acknowledge that while the decision to use substances is absolutely a choice, nobody chooses a life of addiction. That's not a choice. And what I would put to somebody else who maybe have that belief is, when did you choose to not have an addiction? When you were experimenting with substances, when did you make that choice and say, I'm not going to develop an addiction. I'm not going to have compulsive use, right? It's like the same sort of thought experiment as what we would have with somebody who has sexuality, right? If homosexuality is not a choice, right? When did you decide to become heterosexual, right?
Right.
So anyway, that's my little rant on stigma. So, and part of what I would like to put some teachings on with regard to this concept is relating back again to how substances act on the brain. And I want to extend what I was, self-stigma is a killer for sure, Bonnie. I want to extend that concept of how substances act on key brain regions, like you said, that are involved in decision-making. So back to this very front anterior portion of the brain, which is called the prefrontal cortex right here. It's the most recently developed part of the brain. So when we look across evolution, when our brain was evolving and changing, right? So this is what we have today as Homo erectus and Homo habilis is very, very different than from the early hominids, right? So we added brain tissue more and more to the front part of the brain as we became more complex and had higher order cognitive capabilities. So language, thought, etc., are all located in this very, very anterior part of the brain, which all this is the frontal lobe, and then the very front part is the prefrontal cortex. And what I would say is like the CEO of your brain, right? The chief executive officer. It has a lot of connections, so neural tissue that goes back to those other lower brain regions that are mostly inhibitory connections, right? So imagine you're on a diet, right? Your very back part of your brain is saying, eat that brownie, eat. And this part of the brain is saying, don't do it, you're on a diet, right? So it's saying, shh, be quiet, be quiet, right? Now, in substance use, what we know is we have these brain regions that are activated that's saying, oh, what you're using, it's making me super excited. Yum, I like this. This is amazing. I like how it makes me feel. And it's sending those signals back to the front part of your brain that's saying, plan for this in the future, plan for this in the future. And initially what the brain does is go, no, too much. And it tries to quiet it down. Okay. But with repeated use, that quieting down, it becomes, there's a new homeostasis or steady state that's achieved because you're overriding it with chronic use or regular use. So over time, this part of the brain that is normally saying, don't do it, you've got to go to work tomorrow morning, you've got your kids to take care of, right? It's saying you can't plan for this. That part of the brain, the connections become weakened. And what that means is it's kind of like that silent overlord is no longer having its capability to silence this very lizard brain, do all the good things that are amazing and awesome, right? And so that's what I would say why substance use disorders, even behavioral addictions, I do believe that, gambling is very real. Sex addictions, I do think there's a reality there. Even certain types of eating disorders, like binge eating disorder, they're very, very hard to get out of that pattern, the habit and the compulsive use, in part because the hardware that is normally engaging in decision-making has become compromised. So the way I like to characterize it is, we know, the brain has many different ways that it makes decisions, and one of them is a problem solving, right? You're deep in thought, like how do I solve this difficult problem? And then another way of making decisions is very automatic, right? And that automatic decision-making system in the brain is typically active under stressful circumstances. You don't want to spend time and energy thinking through a problem when a hungry bear is chasing you. You want to rely on tried and true escape mechanisms to deal with this very, very real threat of a bear coming to chase you. So when you're under stressful circumstances, your prefrontal cortex goes offline. It's like, nope, we got to rely on that basal ganglia, that lower part of the brain, to engage in those very tried and true ways to cope with this stressor. And that's what happens with addiction. These parts of the brain become less strengthened, and this part of the brain becomes very strengthened. That decision-making process, it's always life or death, right? And you'll hear this from people who are actively using. If they're between a hit, right? They're between and they feel like they're dying, right? And they may actually articulate this. I feel like I'm dying. They feel like under threat because that part of the brain is literally signaling you will die if you don't get a substance, right? Okay. And so again, back to that packaged, very long answer, but this is why substance use disorders involve challenges with judgment and reasoning and goal-directed behavior, because those parts of the brain have been changed. They are literally, what drugs do is they overtake those brain regions to kind of teach the individual the only things that's important for you to pay attention to in your environment are the cues and the events that predict drug. Everything else is unimportant. And it gets to the point, like severe, like chronic addiction, it could be, you're putting like kids, right? Like careers, hygiene becomes compromised, right? Because the only thing, like we say, it's a narrowing of the behavioral repertoire. It's like the only thing that's important is getting my next fix.
So is that kind of similar to putting yourself kind of in a state of, or not putting yourself, but the substances put your brain in a constant state of fight or flight? Is that yes. the same thing?
Yes.
Okay. Yes. And we have a couple of questions actually coming in from the viewers. One from Ellie Lawton says, what about those who are forced to do alcohol and some drugs?
Right. So, first of all, that's awful. And I'm sorry that, whoever that happened to, that's, it's not by choice, right. As well, and I have heard of this in some, like even survival sex situations where somebody is working with their pimp, or somebody is actually forcing drugs on them. I would say, like, my psychology background says it's a very different process, because even animal models of addiction, some of them involve like experimenter administered drug, right? So you're actually injecting the animal with a drug, versus other models of addiction where you train an animal to like press on a lever to get an injection of a drug. We call the first thing non-contingent and the second contingent drug administration. Non-contingent meaning it doesn't depend on your behavior. You're not actually engaging in the behavior to get the drug. And that involves a different series of brain regions than the contingent drug administration. You would see slight differences in just behavior with the first over the second. So if you're being forced taking drug or administering it, somebody else is administering it, it's going to affect different circuits in the brain, but you will still see a process of dependence that will occur because the drug is still getting into the brain and acting on those brain regions involved in pleasure and fear, etc.
Okay. And our next question. That's an excellent question. Yeah. Our next question comes from Bonnie Heilman. It's like the decision-making part of your brain just shuts off and lets your craving call the shots.
Exactly. Yep. That's a great way of putting it. And last name almost similar to mine.
Heilman, yes. Yeah. And Linda Shaw would like to know, so how do some people overcome that brain dysfunction to decide to get help for their addiction?
Yes, and I don't know if we want to get into it now. It's up to you, Donna, but for sure we were going to talk about this. Yeah, so, I touched on the concept of plasticity, which is the idea that the brain is constantly changing. It's constantly adapting to your environment, which is really, really adaptive. And that means that it helps with our survival. Like, imagine moving from a hot climate to a cold climate. You have to learn to adapt to that cold climate. And your brain circuits involved in thermoregulation or maintaining body temperature will be changing to account for your new climate. And in the same way, when we take substances, alters are the brain systems that are involved in reward and pleasure. So we talk in biology about the concept of homeostasis, or steady state, right? Your body wants to maintain a constant steady state of things like water balance, salt, sugar, and by the same token, you want to maintain a constant balance of reward or pleasure. And your brain, when you're taking substances, that balance will be disturbed. And so that's the brain kind of altering and changing in response to the drugs being consistently on board. But much like the brain will change in response to substance use, and it will, you'll have those circuits that confer addiction, the brain can also change towards wellness. And that's a really important and hopeful point, is that it is possible, and we've got people like, here that are speaking to this. It is possible to live well and in recovery, whatever that journey means to you, right? I want to emphasize that, if abstinence is your recovery endpoint, that's great. If using less harmfully is your endpoint, if it's using cannabis instead of opioids, that's, whatever. If today is a little bit better than yesterday, that's living better, right? That's
Yes.
the wellness journey that you're on, and your brain will for sure alter in response to that. You will always have drug memories. So Donna and I were talking about this earlier, like the memory of the drug will never go away. Your brain will always remember that. And that's why it is work to be in that space, to continue to contribute towards your wellness journey. And there are things that you can do that can help that, right? And I always say, like, you have to have a big toolbox, right? What's going to work for one person isn't necessarily going to work for another person. And maybe it's not just psychotherapy, it's also medicine, right? It might be substitutes, opioids, managed opioid treatment, yoga, meditation. Like I was saying earlier in our conversation, like things like even aerobic exercise, which is like, what? Well, you would not think about that. Aerobic exercise, like that what that means is like your oxygen is really being used up, right? It's not like weightlifting is anaerobic, like going for a run is aerobic. It's pumping your bloodstream, pumping all this lovely glucose up into your brain, and you're actually activating growth factors that are involved in the plasticity of your brain. So you're really shaping your brain, and you're also contributing to good stress control. So there's things like lifestyle factors, exercise, diet, sleep. And I know most recovery treatment places emphasize these so-called psychosocial factors that are really, really crucial in wellness. So there are things that you can do to continue, like anything you're doing for your brain, you're going to do for your mind, right? So for sure, the plasticity of the brain continues well beyond the drug journey, and you can engage in these wellness activities, thinking, being, that can alter your brain and be in a place where you're living well. And that's really what we want for all our Canadians, right? It's living well.
So just to backtrack slightly here, and we talked about this earlier before the show, the analogy basically of the egg in the frying pan is not accurate. Then, from what you're saying now, it's pretty clear that was
any child of the 80s, right? Would know this, like, this is your brain, and it's like the egg, and this is your brain on drugs.
That's right.
And it's like the smashed egg in the frying pan. It's like sizzling away, right? And what was it? That was the Nancy Reagan Just Say No to Drugs campaign that was very dominant in the 1980s up until the 1990s, which I would argue was not effective. It was scare tactics, and there, like, I could go on and on, like from a social justice perspective about like all the racist ideologies that underpinned a lot of this anti-drug campaign. But the belief was that if we scare people, right, and they're still being used to this day.
Absolutely,
these scare tactics, right? Going into schools and that's going to prevent drug use. Okay, well, that's not a really good harm reduction approach, because any teen who then uses a substance and realizes the next day my brain isn't turned into a fried egg is going to tell you this, and then they don't trust, right? They don't trust the messaging that's coming from government or their teachers or what have you. So what that led people to believe is that when you take substances, it literally kills off all your brain cells, which is inaccurate.
Okay.
It's the concept of neurotoxicity, which is a fancy word that means killing off brain cells. The only drug that we know to some extent is neurotoxic. It's a teratogen, is alcohol, which if you consume alcohol while pregnant, this does have significant impacts on the developing fetus. And it can lead to very, very significant changes in the developing nervous system of the fetus. But let's leave that to the side. When we're taking substances as adults, it doesn't kill off your brain cells. It alters those pathways, right? So yes, it changes your brain, but it's not necessarily killing off all your brain cells as a direct result of the alcohol or heroin or what have you. That said, put that concept to the side for a second. Stress does. And what do we know? So what do we know?
I'm laughing because we were talking about this earlier. It's
So stress is actually neurotoxic, and it can kill off brain cells involved in actually controlling your stress response, and cells that are located in parts of the brain that govern motivation and emotion. And so as a side effect, I don't know if I can even say that, but substance use disorders involve stress, right? Those stress systems are at play when we're using substances. So yes, do we have cell loss? Possibly. It's very, very hard to demonstrate this in human studies, right? This is something that ethically we just can't randomly assign a population of people to, you take this drug and nothing else, and let's look at your brain. And another problem, we just can't ethically do it. We have animal models, but they're not perfect. So yeah, that, just to go back to the question, the frying egg doesn't happen. It does change your brain, but it isn't just that severe, like initially, as soon as you inhale crack cocaine, suddenly your brain is going to get fried up. No. No.
Okay. Well, that's a relief to hear, because I believed that marketing when I was young. And like you pointed out, up until I tried something for the first time and I woke up the next day and I was fine. I was, and then, that skepticism set in. So I'm just going to go to a couple comments, or comment from our viewer, Kelsey Dumont. She'd like to know, I've heard educated persons discuss that some people have genetic component that makes them less resilient to combating substance use disorder or addiction, i.e. easily succumb to addiction. Is this a component of those genetic polymorphisms that you discussed, plus environment?
Yes, Kelsey, absolutely. That's correct. So there are these gene polymorphisms that if you inherit some of them, or if you inherit them, that coupled with the environmental input can certainly render somebody, as you say, less resilient or more vulnerable. And there's brilliant research that's done in this space, originally in depression. So they were finding these copies of a certain gene, serotonin, I'm sure we all know is involved in mood, that is implicated in depressed states. And they're called these short and long alleles. It's literally the length of the actual allelic, which is the part of the gene that you inherit from mom and dad. These short and long alleles that, in combination with early environmental trauma, would render an individual more vulnerable to depression. And then I've done some work with my colleague, Dr. Robin McQuaid, where we're looking at gene polymorphisms of the endocannabinoid receptors, which we know we have an endocannabinoid system in the brain, which is why cannabis products impact our brain states, because the active ingredient in cannabis, the shape of it resembles the endocannabinoids in our brain. So they bind to the receptor like a lock and a key, and then they activate the brain regions involved in memory, emotion, and pleasure. And so these cannabinoid receptors, you can inherit these polymorphisms of them. And what we found, we ran a study where we looked at students, we were looking at undergraduate student populations, and the copies of these genes. And then we asked students, to what extent did you experience early life trauma? And students that had experienced severe early life trauma plus had this specific gene polymorphism scored higher on a cannabis use dependency test, right? So they were using cannabis more problematically than students who did not have this copy of the gene and yet still also had early life trauma. So that's exactly it, Kelsey. Your question is like, there could be two people that experience like very similar levels of trauma. One of them might not develop any psychiatric illness and another will, and it could boil down to these gene polymorphisms.
Fascinating. Next question comes from Bonnie Heilman, and she'd like to know, how do you communicate with someone when they're in that irrational state, when their brain thinks they'll die if they do not get a fix? How do you get through to them to let them know it's not their fault and they're loved and worthy and there's a way out?
Well, that's hard because, as we all know, even when you're not in a place where you have a substance use disorder, many of us experience these highly anxious states, right? Or highly fearful states, regardless. And it's very, very hard to have, like you said, Bonnie, so eloquently, these rational conversations, because you're literally not thinking rationally. You're just thinking about like getting through this moment. So I would just say it may not be the time, right? And maybe if it's between use, I would say the message of just always being there for that individual is really, really important. And you said it so nicely in your second half of your question about just being there to support an individual, regardless of where they are in their journey. And that can be really, really challenging. That's the number one question I get is, how do I support a friend or a family member or loved one who is in the part of their addiction journey, their high using state, they're not well, you're seeing they're not well, how do I support them? It can be really, really difficult. This is not my area of expertise. I'm not a clinician or a practitioner, but there's lots of great spaces and resources and supports for individuals, including the SMART program, I believe. And Breaking Free Online has some supports as well. But I channel my dear friend, Gor Garner, who's lived, living well, 35 years active addiction, who is my mentor. And he says the best thing that you can do for somebody is take care of your own wellness, right? That's your gift, right? To take care of yourself, and to know the resources and supports that are available to them. And I think I take that very seriously as an ally to the substance using community, but also to my students, who some of them may not be well, and it may not be substance use, it could be mental health. What I do for them is I educate myself as to the resources that are available to them on campus and off campus, so that if they come to me, I can support them. And I know it's a hard space when somebody is in that, they're not well, you want to support them. As you say, how do I do that when they're in this, I just want to die, I just want to get my next fix? Really, really hard. And I'm afraid I don't have a really good answer for you, other than just keep communicating that you're there for that individual. And ultimately, at the end of the day, we know we can't force anybody into wellness. It has to be their own individual choice. And I'm sure Dawn and Dan can speak more about this than I can eloquently as to their own journey, but it's tough, really, really hard.
Moving on, I'd like to briefly talk about legalization. One of the questions I had for you in our pre-interview, and it relates to the cannabis use on campus, I'd asked, is there a correlation to legalization in 2018 to increase usage?
Yeah, so this is one of the government is really interested in this answer, public health, internationally, right? Canada is on the world stage for being a country where in North America, where we have legal use, and the big question is it promoting use, right? And the initial data that came out of Health Canada didn't really show, it was kind of messy. There was a little bit blips here and there. And I should mention that the population of users, the demographic that is the most highly using demographic, I should say, is young adults, right? So 15 to 29-ish, right? Depends on your definition of that. And so that was also, given brain development, this is also the population we're really interested in, right? We know that the brain is continuing to change their development well up until early adulthood, I should say. So there were some little blips here and there. The challenge is, so we legalized cannabis October 2018. What happened March 2020? The pandemic, right? Yep. So it is really, really messy data to extract out, because we are seeing elevated use in some instances, but it's really hard to say, is that legalization or is that pandemic coping? The one population we're actually seeing increased use in, and I've got lots of colleagues, Dr. Kim Carace at the Royal Ottawa Hospital, for example, really interested in this question, is older adults. We're seeing an increased use. So that's, I think, 55 to 65. And if you go to a cannabis shop, I don't know if anybody has been, I go into them just to do research, right? You can see, like the demographic is very much, you can see older adults, and I think it could be like the deadheads from the 60s, or like the flower children of the 70s that are okay, but I am a big proponent of legalization. I should say, I think it's really important that drugs are legal, and that allows us to do education. and awareness about substances, right? And back to the question about cannabis use on campus, this is really important for us to have these conversations with young adults and talk to them about the evidence about use and who might be at risk, and what kinds of cannabis might be more harmful, for example, so that students and people in general can make educated decisions about their use. That's what I truly believe in. It's the harm reduction approach. And that way we're not throwing people into jail for having like we know addiction is not a criminal issue, it's a healthcare issue.
Yes. Yeah, it'd be nice if people outside of this community would come to that realization.
Right? Use your voices. Vote with your feet. Vote with your hands. Right?
Yes.
Vote your public officials in that speak about substance use health.
So I have one more question from Christina Pekarek. She'd like to know, is it possible to get epigenetic testing to understand how trauma and addiction are factoring in? Is it available on a clinical basis, or is this only being done in a research setting?
Christina, excellent question. And I would say you're peeping into the future, right? The concept of personalized medicine is very much on the horizon. So if you're interested in this topic, the short answer is no. Okay, so I'm going to tell you that short answer right now is no. The long answer is possibly in the future we may have this. So if you're interested in this topic, I did coincidentally, and I swear this wasn't planted, just interview somebody for my podcast called Minding the Brain. If you're interested, mindingthebrainpodcast.com. You can go to our website. We're on all the major channels. Called Dr. Benicio Frey, who is one of the scientific directors of what's called CanBind, which is the Canadian biomarker for depression. Network for depression. And I'll tell you this in the context of depression. I promise I'll come back to addiction. So in depression research, what they're looking at is they're discovering that there are certain biomarkers, of which things like genes are a biomarker, right? There could be also inflammatory factors that you can get, you can measure as well. There's brain imaging, right, that you can do. You can look at brain signals on the surface of the brain, or you can look at like an MRI, resting state MRI. So these so-called biomarkers, they can't diagnose depression, but what they can do is what these researchers are finding is they can predict how you'll respond to a given line of treatment for depression. So for example, which antidepressant might be the best for you given your constellation of these biomarkers. So I'd say this is speaking to the future of not only depression, but also things like substance use disorders, because we know substance use is often associated with complex PTSD, and there are biosignatures for PTSD. So that could be something that eventually in the future you go to your doctor, you get a diagnosis, they run all these tests, and they can say, okay, well, for you the best course of treatment is X. I mean, for me, I'd love to see like preventatively, like even like way down the line, like we should be implementing the average childhood experiences scale into everybody that comes into a doctor's office for the first time. So we can assess people's trauma histories. And then we know that they're a more at-risk population because it has all these health consequences, not just psychiatric. Cancers, cardiovascular disease, stroke are all predicted by early childhood adverse experiences. So sorry, again, I'm long-winded in my answers, but I'm just so excited to talk about this stuff. But yes, I think right now, no, we don't have that diagnostically, but I would say that this is certainly where the future is going in terms of us being able to understand not only prediction for health, but also how best to treat it.
That's super exciting. I look forward to that actually taking place. So I do believe that's everything that we have for questions and comments coming in, Doctor. Is there anything you'd like to leave us with today?
Just to remember that wherever you are in your journey and wherever somebody is in your life that might be struggling with addiction or living well with an addiction, let's all just extend them compassion, because I think we can all use a little love and compassion. It's never a bad thing. And it can be really hard to be somebody who is like directly, with somebody who's in a really terrible place or struggling. That is really hard. So I hope whoever you are, and if you are in that space, you're also getting support. And I extend you some compassion as well.
Well, thank you very much for your time and sharing your knowledge. It's been amazing.
Thank you for having me. It's also been amazing for me too.
My pleasure. Thank you. Take care.
Take care.
There is power in numbers. If you'd like to contribute to ending the stigma around emotional pain, please subscribe to our YouTube channel, follow on Twitch, Facebook, and Instagram. Like and comment your thoughts on our posts. Let us come together with our lived and living experience as a resource that has the power to engage new thought processes, to promote new ideas, to broaden the spectrum of care, and to show the world that we can recover. There is a safer way, and we're here to show you how. Take care, everyone.